Okay, in the previous class we learnt about the Petrov's equation derivation, which is essentially given by f is equal to 2 pi square eta n dash by p into 1 by xi. So xi is diametral clearance ratio. Next, there is one more equation for finding out coefficient of friction in oil film given by McKee. So it's called McKee equation given by K suffix a into eta n dash by p into 1 by xi into 10 power minus 10 plus delta W, where Ka is equal to 1.95 into 10 power 11 for a full journal bearing. Okay, and then you have got delta mu is equal to a correction factor to avoid end leakage, that is given by 0.002. So when you take this, so this equation will give you the coefficient of friction in an oil film by McKee, and whereas this is the Petrov's equation for finding out coefficient of friction. Then we have got two more important parameters. One is heat generated and another is heat dissipated. So basically, due to viscous friction, lot of heat is generated in a journal bearing. So essentially the heat generated is given by coefficient of friction into P into L into D. Essentially D into L is the projected area and P is the unit load, and U is the velocity, that is essentially given by pi dn by 60. That is U is equal to pi dn by 60,000 will give you the essentially velocity in meters per second. Next comes heat dissipated. So heat dissipating character of any journal bearing is dependent on coefficient of heat transfer, difference in temperature, okay, and the projected area of bearing, that is D into L, and then you have got difference in temperature delta T, and K is the coefficient of heat transfer. Okay, so this coefficient of heat transfer K for light construction, and in still air we take it as 0.475, and we take for heavy construction and well ventilated bearing we take K is equal to 0.273. So essentially we calculate coefficient of friction either by Petrov's equation or by McKee equation, or in many cases we calculate coefficient of friction both by using Petrov's equation and McKee equation. In McKee equation, this Ka is 1.95 into 10 power 11 constant value for full journal bearing, and delta mu is correction factor for end leakage, which is given by 0.002. So substitute these values over there, and as we know, xi is diametral clearance ratio, that is capital C by diameter of the journal, or radial clearance by radius of journal. Okay, and then as I said, so a lot of heat is generated due to viscous friction, so we need to essentially calculate heat generated given by coefficient of friction, unit load, length of journal, diameter of the journal, and velocity of the journal. We are given by pi dn by 60,000. Heat dissipated is given by change in temperature, area of the journal divided by the coefficient of heat transfer for light construction, and in still air we use K is equal to 0.475, and for well ventilated and heavy construction we use 0.273. So these are the equations that we need to use to calculate coefficient of friction, heat generated and heat dissipated in case of lightly loaded bearings.